Hi, so my name is Maciej Kwiek. I work as a software engineer at Mirantis in Poznań, and I came here to talk to you a bit about boosting Helm with AppController, or how AppController can provide orchestration capabilities to Helm. So this was originally a lightning talk at this year's KubeCon Berlin. I added some slides and it's a bit longer, but hopefully it won't take enough time to bore you. So yeah, so let's start. First thing, how many of you heard about Helm? Cool. And how many of you, well, it's Kubernetes meetup, but I will ask nonetheless, how many of you heard and know anything about Kubernetes at all? Cool, that will make it much easier. Okay, so Helm is a package manager for Kubernetes, right? It's a package manager for your cluster. It's like apt-get for your Kubernetes cluster. You can install applications on your cluster with it. At least it aims to be it. And this talk will talk a bit about how it can help Helm. How AppController project can help Helm achieve this state of affairs. So Helm is super awesome. Like sometimes it doesn't work, but most of the time it works quite well. At least I hear that from my colleagues at operations, and people seem to like it. It supports dependencies between charts. So new word, chart. Chart is a Kubernetes application that is being deployed like Helm. So it's a package. Helm chart is a package the same as you can have a dep package for apt-get. So it's an application that you deploy. It can consist of other charts. It can depend on other charts. It can have several Kubernetes objects in it. Basically, when you say chart, it's an application that you deploy in your cluster. But Helm provides no orchestration. So generally in Kubernetes, you don't really need sophisticated orchestration, right? Because in Kubernetes, we have this you just put everything into the cluster and you expect that the containers that are running in cluster are made in a way that will make them converge into the working state eventually, right? So they can restart several times. You don't care if you can wait like 15 seconds or a minute or a bit more time until all containers are talking to each other and running. Then you are happy and you don't care about the restarts. But there are some applications that actually need orchestration, like OpenStack. You can't really install OpenStack Cloud with this stuff. So AppController, the project I will talk about later, initially was created as one way to actually try to run OpenStack Cloud on Kubernetes cluster. I know it sounds silly, but hey, at least it's fun. Yeah, so basically if you need orchestration, because sometimes you need it, you write it in your init containers. So this was also the path that we did at Mirantis, like initially for OpenStack. So there were init containers with start script inside the init container. The init container was waiting for other components to be online. So after they became online, the main container started and everything should have been fine. And it's okay, it's proper approach, it works, but we thought that there can be, that this could be done in a slightly different way. Maybe we could centralize it a bit, maybe we could have logs in one place instead of spread inside many containers across different pods. Yeah, you can also write an operator, right? So CoreOS is writing operators. It's basically as far as my research goes, CoreOS operators are it's a definition on how you should write, how you should code your deployments, right? So it's maybe, I don't really know Terraform, but from what Kamil said, it sounds a bit like Terraform. If I'm wrong, you can tell me I'm wrong later or now. Okay, I'm not wrong. Cool. Or I just don't know it. Yeah, but you can also do it, right? There is another way for it. It's not like AppController. The stuff that we are doing is the only proper way. But you can use it. And I will talk about how you can actually integrate it with Helm. Yeah. So here you can see the Helm architecture right now. So it's really simple, right? There's a client. It gets input from user. User either wants to install something, user wants to list the deployments, user wants to see what resources are in this deployment, user wants to roll back, upgrade, delete stuff, right? Just like he would want to see, just like the stuff he would want to do in a with normal package manager, not in the cloud, but on your laptop or something. Yeah, so this is the client, and there's a server. Server is called Tiller. It receives user inputs and acts accordingly. So it creates objects, retrieves them from the cluster, etc. Tiller lives inside the Kubernetes cluster you're running it in. When you install Helm, it creates a deployment called Tiller, and the pod just waits for gRPC calls from the client to do stuff. Yeah, so we decided that it would be nice to actually plug something into this architecture. So this was the stuff that was done within the community. It was quite nice. There's some really nice people from Days, which has recently been bought by Microsoft. Some really nice people work on Helm. And Helm was recently the first project to actually exit the Kubernetes incubator, so it's now officially incubated Kubernetes project. So I guess it's kind of official that it's the package manager for your Kubernetes cluster of choice. Yeah, so this was just a digression, sorry. Yeah, so we want to plug something into this architecture, and we figured out that we will have one more microservice that will also live in the cluster, maybe in the same pod, maybe not. It doesn't really matter. That will actually do stuff. So Tiller, as you can read in the Helm documentation, Tiller manages your resources and manages your deployments and the stuff that you install. But the actual stuff that is being done is now, right now, as of master, like 3 weeks ago, can actually, if you enable experimental mode, is actually done by Rudder, which is a pluggable backend which you can plug in, and it's another microservice that we added to the mix. Yeah, so it can create, upgrade, rollback your Kubernetes objects that are part of your releases. So Rudder is an interface. Communication to it is done via gRPC. We figure out that Helm talks to Tiller via gRPC, so why complicate it? So as long as it implements the gRPC interface defined by Helm, you can write your own Rudder. Here's the proposal, and its merged in Helm master should be released in Helm 2.5, which should be around the time frame of Kubernetes 1.7. So yeah, it's kind of real. It's there, right? So this is nice. But I didn't talk anything about orchestration yet, right? So first off, we have default Rudder, which works exactly the same way original Tiller works. So nothing is orchestrated. The orchestration is put everything into the cluster. Right? But as I said earlier, this is normal in Kubernetes world. Most of the time, this is what you want. Helm people knew what they were doing when they did it this way, right? So yeah, you have WordPress chart, there's a dependency, and all the deployment services, persistent volume claims, all this stuff is just shoved into the cluster, and eventually you have your WordPress working. Only WordPress actually fit on this slide, so sorry about that. Yeah, so now we can move to AppController. So AppController is a project that all it does is orchestration. It's focused on orchestration solely, and it's focused on orchestration inside Kubernetes cluster, because you have orchestrators that that can be more generic, but we wanted to have something that feels really Kubernetes native. So that gives you the feel that you are that it's a working part of Kubernetes ecosystem, that it's not just shoved in there without without thinking. We really tried to design it in a way. Yeah, I guess I told what I wanted to say. Yeah, so all it does is orchestration. The way it works is you define your deployment graph and you store it in Kubernetes storage as third-party resources. So third-party resources are a way in Kubernetes in which you can extend the REST API, so you can create new endpoints in which you can then create new objects. So it's better than talking directly to etcd, because talking directly to etcd is wrong, as you can read in Kubernetes documentation. You always want to have a proxy of Kubernetes API, because you may not know where the etcd that cluster uses is. There may be really weird stuff down there, so it's really easier to just create a third-party resource, have a new endpoint, and have it working for you as a storage. Yeah, so it also, as Tiller, it runs as basically as a pod. The easiest way you can deploy AppController in your cluster is to run it in a pod. You can also run it outside of the cluster for development purposes. It's often easier to just compile it and run, but basically when you don't develop it, when you're just using it, you want to have it running in your cluster. Yeah, and in order to run it, actually you create a config map which defines your deployment. So when you have all your deployment graph data loaded up in your cluster, you have resource definitions and you have dependencies. So resource definitions encapsulate all Kubernetes objects that you can have, deployments, pods, replica sets, daemon sets, stateful sets, patch sets until 1.5. Persistent volume claims, all this stuff that consists of all these Kubernetes objects are wrapped in the third-party resources. And then when you create this config map, which basically means, hey, AppController, please run my deployment graph, it reads all the deployment graph data that you put into your third-party resources, and it starts to deploy it. I will go into some more detail later. Yeah, and AppController also has some advanced status checks. So it's possible, for example, to define success factor for replica sets or deployments. So if you really don't care, if you want your deployments or replica sets to be deemed ready, if they have only 1/3 of the pods being ready, then it's okay, you can do it. You don't have to have 100% of pods in your replica set being ready all the time, because, well, sometimes it's not really possible. Yeah, so how the AppController rudder works. First, I will talk about the rudder, which is the pluggable backend for Tiller, which is a Helm server. And after that, I will go into more detail talking about how AppController actually works. So we have the same chart as I've shown before. We have WordPress, we have MariaDB chart, and there is a dependency between them. So when you run Helm install stable WordPress, it also knows to install MariaDB. So what AppController rather does is it intercepts well, not really intercepts. It gets what needs to be created data from Tiller via the gRPC call, and it infers dependencies in the graph. So right now it's kind of stupid. It definitely could be done better. All components from the parent graph are dependencies for all components of the child graph. So obviously this could be done better, but this is kind of still in a phase of maybe it's a bit after proof of concept, but it's not really mature tech yet. So sorry about that. Yeah, but basically we have dependencies. So all this stuff is again shoved into the cluster, but now it's not actually created in the cluster, because all we did was create third-party resources which are not used in any way by Kubernetes controllers. So if we create a deployment object through the Kubernetes API, it automatically creates a replica set. When the replica set is created, it automatically creates pods beneath this replica set, and so on. And of course, the containers are run eventually when there are pods. But when we create the third-party resource, it just sits there and it waits for another controller, in this case AppController, to actually do something with it. So it is shoved the same way we did it before, but Kubernetes does nothing with it because it's wrapped, it's concealed from Kubernetes, and it cannot yet do anything with it. But we want it to do. We want it to be so because we don't want to shove. Well, obviously with WordPress and MariaDB, we want to just shove it all into the cluster, but as I said in the beginning, it may not be the case for all your needs. So what also is interesting here is that dependencies are also created in the cluster as a third-party resource, right? So we have definitions and dependencies. Yeah. So then we create a config map which triggers deployment, and the deployment basically this deployment ensures that that the WordPress objects, like anything from the WordPress object, won't be created before all MariaDB objects are ready, right? WordPress is a bad example of this, but when you have stuff that actually needs to be run in some topological order, it can help you. And WordPress is just a poor example that. Actually, I think every demo in Helm community that I saw just uses WordPress, so I guess it's kind of tradition now, and I didn't want to destroy it. Yeah. Okay, so this is how AppController Rudder works, and now we can go a bit deeper in how AppController actually works. So this is basically most of the AppController architecture. Will go through the simple path. So first of all, you need to have AppController pod, right, inside the Kubernetes cluster. So you need to create it by, for example, using a manifest inside our GitHub repository. Then AppController pod in the init container creates third-party resources. So there are resource definition and dependencies, as I said before. Then here it says kubectl operator. In this case, in the case that I'm talking about, the stuff actually creating resource definition and dependencies will be AppController Rudder. When operator runs Helm install stable WordPress and the Helm knows that it's using the new deployment engine, and this new deployment engine is also deployed in the cluster, it will actually go through the through AppController Rudder and create resource definitions and dependencies. After that, the deployment starts. Yeah, so basically what happens here is AppController pod retrieves status of Kubernetes objects. If there aren't, it goes topologically through the deployment graph. When it starts from root, there can be several roots in this graph actually, because you can have many nodes in a graph that don't have a parent. It retrieves status. If the object isn't in the cluster, it's getting created. If it's in the cluster, its status is being checked periodically until it's ready. When it's ready, it is marked as ready, and and after that we go through to the another node in the graph, and in this next node in the graph we check for its presence in the cluster, for its state, if it's in the cluster, and if it's not in the cluster, we also need to check if the parents are ready, because without this check, this whole talk would be really not not needed for anything, right? Yeah. So yeah, creates when dependencies are met. This is what I was waiting for to say. Yeah, this is really. Yeah, so this is how AppController works in a nutshell. There are some new things that are being added right now. There are some rewrites. This is why sadly I won't show you the demo tonight, because I didn't have enough time after recent changes to actually do it. So sorry, I hope you'll forgive me when we go to the after party. Yeah, so the state of the text. So AppController Rudder right now, it lives in its repository inside Helm organization. We actually managed to get it from the guys from the Helm people, and it's being implemented slowly but surely. So deployment graph is derived from chart dependencies, right? So you can have chart that depends on several other charts, so it will this will be the only dependencies that you will see in your AppController deployment graph. But in the future we want also to have chart dependencies. You can have an application which is really atomic, but can have some stuff that you want to orchestrate within the chart itself. So we want to talk with community about it and see if there's any need for it, and if there is, we want to change Helm chart format to actually do it and see if there's a need for it. Any questions?
What about application upgrades? Does this whole model of deployment supports upgrading applications?
Yeah.
And what about rollbacks when we are adding?
Yeah, sure. Okay, so Helm itself supports both upgrades and rollbacks. And currently AppController also started supporting upgrades and rollbacks. So what is being done now, this is what I said about the slowly but steady implementing it, is the support for upgrades. And in Helm, actually rollback is upgrade with a previous state. So you don't really differentiate between these. So yeah, it's going to happen, not yet, but if you have simple Helm, if you just want to use Helm, upgrades and rollbacks are actually there.